Okay, guys, so today we assembled here to get to know exactly how we are combining these distinct two domains, data science and astronomy. Okay, so people are actually so much inspired about learning about astronomy, and obviously data science is the leading industry domain, right? So everyone would like to have a career with the data science, and obviously learning the data science and practicing data science, becoming excellent in the data science is not a big thing. Again, understanding each and everything about astronomy, it may take a little while, but that is not also a big stuff. The thing is how to blend these two ideas together, and thereby how to power up ourselves in our career. Okay, so if we set our career of what we are doing with more interest, what we are doing with more care. Okay, that career something definitely like very very impressive, right? So we are usually working people who are working in industries, especially coming from computer science background and working in industries as a data scientist or developer or AI developer or any other developer roles. Sooner, this is my experience. Okay, I'm not actually downsizing anyone. This is my experience. Sooner they lose the interest because I came from the IT background. I was an aerospace engineer. Okay, I was an aerospace engineer. I used to have around 12 years of teaching experience. So I started my career in IT as a machine learning developer because I knew the data science. I have done some training there. I trained people there. So I started my career as a machine learning developer. All of this when I realized this is something quite not good. Okay, maybe we need to find a way how to blend all these data science ideas into astronomy, which is something like a ocean, and how to get the best out of it. Okay, that is why I am here in Spartificial as a head faculty. So I am conducting this webinar to share my experience, how I learned everything from the scratch in astronomy as well as in data science, how I blended it, how I am pursuing it. Okay, I'm also still a learner. So I am going to exactly give you that. Okay, guys. So this session, please, if you are coming with any doubt while I am taking the session, I guess, Rogan, are they allowed to stop me and raise questions, or do we have to let them
They can,
ask?
yeah, sure, sir. So
Hmm.
basically, if you are facing any kind of difficulties, like while sir is discussing something, and if you are having any kind of doubts, you can always post it in the chat section, and we'll take over these doubts at the end of the session.
Yes, that's the good idea. Okay.
Yeah,
And again, I'm not going to be super fast. I will be doing it in a snail speed. Okay, so very slow, very lightweight mode. So you don't have to worry about that. Just try to understand everything, whatever I am teaching. Then we will have a doubt session where we will take care of everything. Okay, I guess that's the best practice. Okay, guys. So we shall begin. So introduction to data science. This is our first chapter. Okay, so what is actually data science? What is actually data? And what is actually data? So data is actually everywhere, right? Because we are living in a world which is time space, right? Everything is moving over a time ahead, right? So when there's a moving by, we are leaving a data behind, right? We are the human being ultimately come to know that time is running over a clock. So when time is moving by, we are actually leaving a clue back. We are leaving a clue back, leaving a data back. Because we are obviously doing something. That something is obviously leaving some data and clue back. Okay. So that data Some organizations, some people are fetching it, and they are trying to apply some mechanism over it, and they are trying to extract the valuable information from there, converting that information into useful insights. Thereby, they are trying to help us. Okay, we are the human being finally getting the benefit from all the services people are posting, right? People are creating the name of technology, people are creating the name of research, whatever be it, we human being are the one will be getting finally the benefit. It's for our own race benefit. So data is something which is coming out of our activities, coming out of our daily practice. So how to understand that data and how to extract the informations from there, how to use that informations into something else. Could be a business applications, could be research, could be anything else. How to use it? How to use it, thereby how to benefit us. That is the objective of the data science. That is the objective of the data science. Okay, great. Now, what is the history of this data science? So all the digital technology started to evolve after the World War One, right? So this is also pretty much similar to that race. But the recent development happened since 2006. At that time, they have developed a Hadoop. What is this Hadoop? It's an open source data warehouse, but it's a non-relational database. So we will see what's the difference between relational, non-relational, hierarchical, and object, everything. So this is a non-relational database developed back in 2006. It was developed to store the data. It was developed to store the data, especially a big data. What do you mean by big data? Big data can't be seen in kilobytes or megabytes. Okay, it is in terabytes, petabytes. Okay. So big data is something very big. So database system was developed, especially Hadoop was developed to take care of the data, to save the data within itself. Right after that, there's a stream called data science developed along with data analytics, okay, and data visualization. The stream was developed. What is the role? What is the job? What is the ultimate objective of this role, data science role? Not the role, the domain, data science domain. Pretty much similar. Whatever data we are saving in a data platform, use it, extract the information, again use it to do something really interesting, something really useful for the betterment of the society, for the betterment of the society. Okay, so particularly this data science, and the people who were doing the data science started to call us data scientists since 2011, and this data science is now leading a way for a next generation, right? So we are now in the era of digital era of big data. So we are able to gain access to all the data. If you are working in an industry, they are having tied up with various data warehouses. Even if you are doing, I mean, if you are not an industrial person, but you are with academic, you are also eligible to tie up with the big data warehouses. You are you are you are eligible to extract the data from their warehouse. You are eligible to use it and benefit the project or the applications. Thereby, the whole world will get the benefit. This is the history of the data science. This is actually data science. So, how to extract the informations from the data? I'm giving you a very quick example. Okay. If you take out a series, what do you mean by series? Some numbers, like say 10 numbers. If you take out a series, say 10 numbers, and you are going to do an average, so there will be only one number. So that one number is now going to represent all 10 numbers, all 10 numbers. So similar to this set, just imagine you have a 10 set, 10 set, okay, and you calculated average for all 10 set, all 10 set. So when you try to understand the difference between all these 10 set, and when you try to understand what is the biggest value, I mean, what is the biggest portion among these 10 set, you don't need to go through all these 10 set, right? You just check your average value, that will tell the story. So between the data and between the insight, one strategy was there. It's a math strategy, the average strategy. So we used statistics or math there to extract the information, from all those 10 set of data. And now we are going to only depend on the extracted information to understand more about that particular data. Okay, you got it right. So this is all about data science, how to deal with data, how to extract the information from there, and how to use it for the betterment of our own self, okay, our own mankind. No one is going to have the benefit. We are human beings only going to have the benefit. Okay. So this is with the data science. Now coming to data science life cycle. Data science life cycle. Okay. So it started with the problem statement. It started with the problem statement. So if you are pretty much tied with astronomy, only astronomy, you want to do astronomical data science, your problem statement is started with astronomy. Am I right? For example, you want to interpret the galaxy images, a different galaxy images, and you want to know about the correlation between those galaxy images. Okay, if that is your problem statement, first step, what do you have to do? You have to get the data. You have to get the data. So from where you will collect the data? So either you go for an open source or you go for a paid source. If you go anywhere, you will collect the data from a data warehouse or a standard repository somewhere from other servers. You are receiving it. When you are asking the data from other server, they are sending the data from their data platform. That is nothing but database. Am I right? They are storing the data somewhere. When you are asking the data, they are sending it. At the same time, you only want 2 GB of galaxy images. All the images taken related to nearby our Milky Way galaxy. Okay, you just want to check 2,000 galaxies nearby our Milky Way galaxy only. You don't want deep space galaxies. Okay, so you are just mentioning your requirement. Hey, I only want 2,000 images, which should brief somehow about the nearest galaxies. So they will directly give you the image. So no human is sitting there and deliver that images to you. Some technology is sitting there, right? When you are asking with prescription, some technology is sitting there and sending the data back. Okay, that technology is known as database management system. Database management system. So that is giving you data. So you are getting the data. You got the data from a population, from a big data. You got the data from the population. So this is known as data mining. This is known as data mining. Okay. Once this is done, next you are going for a data cleaning. Why there is a need for data cleaning? Even though you got 2,000 images, couple of the images are not making any sense. Nothing. Not making any sense. Okay. So by looking at that blindly, you just got a disappointment and you are just removing it. We can't blame the database management system if something goes wrong. Maybe we write a letter. Okay, you are not doing well. But we got the data. Okay, so we are cleaning it. We are removing the images which is not making sense. Which is not making sense. Then we are going for a data exploration. What is this data exploration? We are trying to understand Okay, we are trying to understand the images you are having in your hand using some statistics, using some mathematics. Okay, you are trying to understand the data. So all these images are now considered as some NumPy array. NumPy array. Okay, there is a Python package is helping us to read the image in the format of NumPy. So all these images now could be able to read through NumPy. So it is attaining the state NumPy array. So you are using some statistic there to understand the data variance, data standard deviation. Thereby you are coming to this decision. Okay, out of maybe initial step 50 images you just lost. Now you are coming to the decision, okay, another 50 image is not a fit, not the fittest one. So you are losing it. You are not taking it for further level. Then you are going for a feature engineering. What is feature engineering? Much difficult, much high complex statistics. Okay, higher grade statistics. You are using those higher grade statistics, and once again you are doing the filtration. You are removing some images. Now the images you are having in your hand are the quality images. Okay, the right images, because you removed all the images not making any sense. Okay, you are having the images only which is making sense. With that images, you are going for a predictive modeling. That is known as data modeling. That is known as data modeling. Either you use machine learning or you use any fundamental algorithm. Doesn't matter. You go for some data modeling. You try to work with its inner part and you try to extract the information out. What is the information? Extracted information, features. You are extracting the features out. Then you are writing algorithm to check the features. Thereby you are taking a decision which galaxy. Okay, I mean I mean each image is meant for which galaxy. What is the difference between those? How do you get that difference? You are just comparing the features. You are just comparing the features and coming to the solution on the differences between those images. Then your outcome, whatever you got from those, you just want to show it to the society, or you just want to show it to your teacher, or you just want to show it to your manager. So you are using some technique, data visualization techniques. You are creating a beautiful dashboard. Okay, you are creating a beautiful dashboard and you are just expressing the outcomes through the visualization so that the observer easily able to understand everything, whatever you try to, I mean, whatever you want him to understand about your outcomes. He or she easily understood everything. Okay, this is known as data science lifestyle. This is known as data science lifestyle. Here, machine learning is the technology. Okay, got its nose, put its nose in everywhere. Okay, in everywhere, all these seven domains. Machine learning got into everywhere. Okay, because this is now becoming super technology nowadays. People are trying to do a lot of experiments, research, and trying to blend the old idea with the new idea. That is what we are doing, right, all the time. This is known as data science life cycle. Data science life cycle. Okay, great. Now, coming to various application of data science. Okay, we don't need to tell, right? Everyone knows this. So when you are, I mean, everyone is somehow connected to the digital. Everyone. I am in this movement connecting to you towards the digital service, right? So everyone is now connected to the digital in their I mean, day life usage. They are playing with the digital services. They are using the best out of it, right? So application of data science goes everywhere wherever digital services used. If you take out social media, you are posting reviews, you are doing a lot there, so you are leaving a data there. Someone will use that data to build some applications. If it comes to healthcare, obviously prescriptions now coming from the patient's history automatically. Okay, so all the data is there, and coming to marketing, sales, travel, automation, banking. Okay, everywhere data science got its nose because we are connected with digital services abundantly. We are connected to the digital services abundantly. Okay, great. So coming to data science tools, this is just a quick introduction about the tools. Okay, so we started with the programming language. Programming language, we have R, Python, Java, Julia, C++, Scala, a lot. Okay, we are using all these packages to build the data science applications. Whoever already worked as a machine learning developer knows this. Only Python is not used there. Okay, maybe by using the Python, you are also able to develop the complete application because Python coming with the framework. But in some industry, people are still making applications or product just by using the Python as a backend or somewhere with the automation part or somewhere in the database part. Okay. In the complete front end part, they are using Java or something else. So it happens, right? So data type tools is actually includes all the programming languages. And coming to data platforms, the distinct divisions are SQL database and NoSQL database. And there are so many databases are available, paid versions or free versions, right? Free versions are having some limits, obviously. We need a data platform and we need tools. What kind of tools we need? We need machine learning tools, AI tools. Okay, so in this machine learning AI tools here in this image includes TensorFlow, Jupyter, and that Brian indicates something known as deep learning. So we will have a detailed explanation in the upcoming slide. As of now, these are also essential, needed. And coming to data exploration and visualization. Okay, data exploration and visualization. Okay, this is nothing but if you find, I mean, you can find here Excel, you can find some packages. There are so many packages coming with the Python doing the exploration. Okay, you don't need to know about the statistics behind it. Just call it and use it and get the job done. And coming to data injection tools. It is again talking about after you got the data, how to put it back into your database, how to use it and put it back into database. Okay. We collected data from database, we used it and extracted the information, we put it back into database. So obviously there are so many tools, so many codec, so many database management languages there, SQL language, NoSQL language. Okay. And finally, development tools. Yeah, we need an IDE. Obviously, we need a working environment. Am I right? So here I listed out some IDE, and obviously, if you want to build any applications, you need a virtual machine that you can have it from DigitalOcean or somewhere. You need a virtual machine also. Finally, to give a shape as an application, as a product, you need virtual machine because on that top only you'll be building everything. Am I right? This is known as data science tools. A quick introduction. So our first chapter is just completed. Okay, we have just completed the introduction. We have just completed the introduction. What is data? What is data science? Who are data scientists? And uh, what what do you mean by data science life cycle? And what is data science tools? Okay, we have checked everything about it. Now it's time to check more about data processing and data management. Data processing and data management. Okay. So this is nothing but a thumb rule. Data will become information. Information will become knowledge. Data will become information. Information will become knowledge. Okay. So as usual, like I told already, we collect the data from a data warehouse. we extract the information, and we convert it into knowledge. This is the objective. Great. Now, we have discussed these terms like data cleaning, data integration, data selection, data transformation in the slide of data cycles. So we are doing data cleaning through different ways. We are doing the data cleaning through different ways. Okay, there is no such only. I mean, very limited. There's no such thing as only limited steps are available to do the data cleaning. It's not something like that. We are doing the data cleaning through multiple ways, but using some strategies, statistical strategies. Okay. And coming to data integration, what do you mean by data integration? Diffusing the data into number of components. Diffusing the main data into number of components. That is known as data integration. We have a tool. We have a pandas. Okay, if your data is in Excel, we have a pandas to safely recover that data into your notebook or in your workspace, and you are able to diffuse it, okay, for the sake of your further data modeling. And finally, I mean, the next one is data selection. Data selection. So after you diffuse your data into a number of components, maybe you don't like few components. You only need a couple of components. So you are doing the filtration. You are doing some sort of filtration. Finally, data transformation. What is this data transformation? You are, I mean, you don't want the particular type for your processing. For example, if you want to convert integer into float, if you want to convert string into integer, you are actually transforming the data structure, right? Maybe when it is in the Excel file, it is in a different format. When it will be coming into workspace, it is getting a new format. Once again, you are playing on it and you're converting it in new format. So data transformation is quite possible. And for example, if it's the image, before you sending that image into some machine learning models, you are doing the pre-processing. You are cropping it, you are resizing it, you are flattening it, you are doing a lot. So you are completely transforming it. So these are all the various elements required. These are all the various elements required to convert the data into information. Okay. At the end, what should be the state of your data? I mean the characteristics of a valuable data. What should be the characteristics of valuable data? That is nothing but it should be accurate, it should be complete, it should be economical, it should be flexible, it should be reliable, it should be relevant, it should be simple, timely, verifiable. Okay. Most importantly, it should be highly readable. Okay. And it should be highly accessible, and it should be taken by the network we are going to adapt for data modeling. Okay, that is really matters. That really matters. Okay. After you just experiment the data and transform it into any state or any format, doesn't matter. When it will be given to a tool or any base model to extract the information, that base model should be able to understand it properly. Understand it properly. That is the main objective. Okay. And coming to data governance, what is this? Data governance. So it's nothing but database security and database development. So this data governance is the stuff falling to two criteria, which is database security and database development. Okay. So why security is needed? Why security is needed? If there is no security, what will happen? Your data will be stolen, right? Someone will steal your data, will use it against you. Okay, you are running an industry where you are maintaining a database and there is no security. And next morning, if you check your database, you will not find any data. Okay, so security must be there. And that key, the security key should be with the right people, the right hierarchy people. So a lot of procedures are there. And database development. Database development is also very, very important. So there's a distinct domain called database management system. People are taking courses on there and trying to learn skills about how to create their own database, how to manage it, how to use it efficiently. Okay. So these are all coming under the category of data governance. Okay. Now we are going to check database management system in detail. Okay, why we are still talking about database, not talking about astronomy. If you want to become a data scientist in astronomy, you really need to know about database management system. Okay, because you will be dealing with big data, big data. Okay, you should know how to handle it from the scratch. You should know how to handle it. Okay, so you should know about database management system a lot. Great. So database management system. So we have a hub, which is a database management system. It is obviously managing a data. Okay. It is obviously managing a data. How it is managing a data? It is first of all defining the data, and it is diffusing it into number of records, and it is updating those records into the database through the query language. Query language is not there just to extract the data, I mean retrieve the data. Query language is there to push the data to the database also, right? So these are all various elements coming with the database management system. How this is working out? So like I told already, there are so many types of database available: relational database, hierarchic database, flat files database, object database, big data. Hadoop was initialized with the feature of object only back then 20 years before. Okay, now they have various divisions. They have relational domain also, I suppose. Okay, so we have like four divisions, the main divisions. Why we have four divisions? Because we are dealing with the big data, it must be having different regions. It must be having a image, it must be having some metadata, it must be having some coordinates, spherical coordinates. Okay, so we need to find which database could be optimal, feasible to hold such different data structures. Okay, so when the user is sending the data to the database management system, it is just understanding it and diffusing it and push it to the respective database. When user want it, it will once again fetch it and give it to user. Similar to other database, when other database reacting to this database, it is receiving the data, putting it into the database, its own database. When such information should be should be coming out from its own database to the next database, that is also possible for particular applications on your real-time running applications. Okay, real-time application. Sometimes on that particular instance, we need to retrieve the data. There are some applications. At that time, the command goes in, it just extract the data, give it back to the applications, and whatever applications give it back, once again it fetch it and give it once again inside. This is how database management system works out, because in astronomy, we will be dealing with a data which is usually a big data. So we need to know about various repositories, open source repositories or paid repositories available all over the globe to support the astronomers with low cost or paid cost. Okay, we should know about that. Okay, that structure coming with these database as a fundamental one. Okay. Now, what is this PostgreSQL? So why I am showing you this PostgreSQL? I'm not voting for PostgreSQL. Why I'm showing this? Because it has a two module, which is PG Sphere. PostgreSQL is nothing but a database. Okay, so it is having a two module. One is PG Sphere, another one is PG Astro. Okay, these modules are there with PostgreSQL. Maybe it is not there with free editions. Okay, I'm not sure. So it is there with PostgreSQL. So it is particularly there to support the handling of astronomical data. Okay, astronomical data. And What are the different file formats normally used in data science? What are the different file formats normally used in data science? Okay, that's the question. So I'm listing different data formats: CSV, text files, JSON, SAS, SQL, Stata, docx, images, numerous data formats, right? And I am also listing here the big data formats. CSV could be a big data. You have to believe me. And JSON, AVRO, protocol buffers, Spark and ORC. These are all actually a big data file formats. And here I am showing you a quick, simple comparison between AVRO, Spark and ORC. Coming to schema evaluation, what is the schema evaluation? It is indicating the relation. How do you maintain the relation between two databases, or how do you maintain the relation between two tables? Okay. So AVRO doing best here, and forward ORC is doing next to AVRO. Coming to compression, this AVRO is doing just ordinary, but forward doing the better, and ORC is best. So how we need to care about the compression? We need to compress the data, right? So we definitely compress the data. Otherwise, what would happen? Your database will be running out of memory. Am I right? So benefits of data compressing. It saves a great deal of storage space. It saves a great deal of storage space. It also speed up the transfer of the blocks throughout the clusters. Okay. Maybe this line is confusing you, but please have a hope on this line. It will it will serve a great deal of storage space. Okay. And what do you mean by this codec? So this codec is nothing but a code or a language, okay, which is helping to retrieve the data and which is helping to place the data, okay, and send the data. Okay, so it is doing a role of compressor and decompressor. So while you are retrieving the data, it just decompresses the data and give the data in its actual size, actual nature. While you are sending the data there, it will compress the data and store it inside the database. Such an intelligent mechanism, right? So data compression is definitely an important one. Okay. And coming to here, some statistics. Okay. So CSV and JSON are easy to use, human readable, common format. This ORC and Parquet is widely used with Hadoop. AVRO is used with Kafka, and these are all quite good on ETL processing. What do you mean by ETL? Extract, transform, and load. Extract, transform, and load. After you retrieve the data from the database, you will be extracting it, you will be transforming it, again you will be loading it. Okay, this is known as ETL processing. Okay, so database management system is making sure a user shouldn't be worrying about ETL processing, shouldn't be worrying about different data structures. So we need to choose or develop a database configuration which is pretty much supporting for various astronomical data types. So these are the data types available with the generic data science. So we will see in upcoming slides how exactly we have data types in astronomical data, okay, especially big data. Great, yeah. So again, this slide is coming extra because we discussed about data type already. So data cleaning, like I told already, we are fetching the data and we are removing the error part. Especially we remove the null part. Okay, most of the data, sometimes if the data is table based one, some slots are actually containing no value, no meaning. Simply it is known as a null value. So we are obviously removing it. And coming to data transformation, again, yeah, we are able to transform it from one data type to another data type for the need of data modeling. And data visualization is again to understand the data through the visualization. Some tools are there which are having the configuration of charts, graphs, and maps. Okay, great. So now coming to next chapter, which is a data analysis technique. Data analysis technique. So whatever we have discussed so far, just the base or the surface. On the surface, what is happening? But under the surface, what is actually going on? That we really need to know, right? So data analysis technique is starting with statistical analysis. So this is the reason whoever want to hire people, employers always expecting data science and data analyst people to have good knowledge in mathematics, statistics. So what are the different mathematics used in data science, which are linear algebra, calculus, probability, then statistics, okay, numerical methods. So these are all these methods are used in the name of algorithm to extract the information, to play with the data. Okay. So this statistical analysis is having a two different domain. One is descriptive statistics, another one is inferential statistics. What is descriptive statistics? As soon as we got the data, we will be diffusing it, we will be cleaning it, we will be processing it. Yeah, but we are not actually going for the modeling, but we are processing it. We are trying to give a good shape to that data. Thereby, we are trying to extract some information to use some data visualization. Okay, till there it stops. The descriptive statistics approaches. Then inferential statistics. Get the inference. How come we have the inference? After we got the right decisions about the data, we will go for the inference, right? We are not talking about machine learning. We are just talking about the data science. There are so many algorithms out there without the use of machine learning to extract the information, okay, and play around with that information. Thereby, again, extracting much better information. Algorithms are there. So it is just working with the structured data which we got from the descriptive statistics. Then we extract the informations, and based on that we are showing some outcomes for the sake of the project. Okay, so this is the main two divisions under statistical analysis. After that we have a predictive analysis. So predictive analysis is where we are including artificial intelligence, machine learning, predictive modeling. So predictive modeling is nothing but a machine learning modeling. Okay, machine learning modeling. How come machine learning modeling exactly different than other statistics, other approaches? We are doing the training. Okay, we are doing the training with perfection. Okay, thereby the predictions would be perfect because we are introducing a huge data, a big data there. Okay, so we are able to do a much better predictive modeling there. This is another mode of statistical analysis. Then prescriptive analysis. See the definition. Prescribe the best possible outcome based on the assessed data. And come to exploratory data analysis. Again we are using some data analytic tools to extract the information and show it. Causal analysis is something different. After you got the inference, you are raising a question to that inference. Why? How? Why something didn't work out and failures in business and professional activities? Similar to this, you are asking the question. Based on that, you are putting the output back once again to the model and you are doing the causal analysis. Okay. But in order to achieve these, we need statistical methods. What are those methods? Mean, regression, sample size determination, standard deviation, hypothesis testing. This is just some samples. Okay, just some samples. There are millions of statistical approaches out there, statistical parameters out there, which is supporting this whole data science world. Okay, but I mean, our knowledge level will be enriched when we will be committing ourselves into numerous projects, because in every project we use different techniques, we use different strategy, we use different statistics, so we are learning it step by step. So after 4 or 5 years of experience in industry as a data scientist, at the end you will be known as chief data scientist, because chief knows much better than junior. What's the better scale there? What is about the betterment there? Okay. Chief knows more statistics. Chief will come to know more about statistics, and chief will have more experience. So chief is able to guide their juniors. That is why chief is chief. Years will count based on that. Okay. So how much statistic you learn while you are developing your data science projects, that really counts your success. It's not something like extracting the command, extracting the functionality from the packages and using it and getting the output. That is possible when we are dealing with tutorial projects. That is not possible. I mean, the industry projects will not be helping in that way. Okay. We need to learn some statistics. We need to learn the strategy, how to tackle everything. So this is nothing but data analysis techniques. And now please have some introduction about AI and machine learning. So here I differentiated AI, machine learning, and deep learning. Here I differentiated AI, machine learning, and deep learning. Okay, so AI, what is this AI? AI is completely task oriented. Okay, what is this task? So you want to predict the road wherever the potholes are. I mean, you want to predict the potholes on the road. You can't do it right while you are driving. Can you able to do it when you are driving with 80 kilometer per hour on a road? Can you able to spot the potholes thereby? Can you able to make a quick turn? You can't. If you are moving with high speed, but even though you are moving with a car of high speed where we have a computer vision technology, suppose you are just putting automatic mode, for example, Tesla cars, it will identify the potholes. Based on that, it will divert and maintaining the stability also. Okay. So this is task oriented. So here the AI becomes super excellence than human being. Consider this AI as a human being, but this human being is far more super intelligence than us. Okay, this is called AI. So in order to achieve the AI, in order to have better results in AI, in order to bring the AI product, we need machine learning. So this machine learning is built on the top of statistics, mathematics, algorithms, strategies, rules, lot. But this is now getting powered by, this is now getting yeah, super here by deep learning. Okay, getting powered by deep learning. So what is this deep learning? This is something known as a subset of machine learning, a new technology which is mimicking our human brain. How our human brain is having artificial neurons. Similar to that, this deep learning is having the artificial neuron. Okay. And there will be artificial network. So it is somehow super excellence than classical machine learning, and trying to help the machine learning to build better outcomes than classical machine learning. Okay, that is why everyone is now thinking about deep learning, deep learning, deep learning. Everything is curious about deep learning. Okay, this is a new technology and doing its perfection. Okay, and this slide is again talking the same in different fashion. Okay. See the artificial intelligence. We are able to do a different task like natural language processing, visual perception, automatic programming, intelligent robot, automatic reasoning, knowledge representation. For that, we need some machine learning algorithms. Okay. These machine learning algorithm includes the idea of neural network and also the art of using the neural network. The art of using the neural network is deep learning. So there will be different state of the art network that is mentioned here: CNN, GAN, RNN, DBA. Okay, these listings coming here in this machine learning are the various machine learning algorithms built on statistics and the strategies. Okay, so everything is working together. Everything is working together. If you take out any applications, you need classical machine learning at certain extent. You need deep learning at certain extent. You need exploratory data analysis part at certain extent. It's not something always, I mean, you would only need deep learning everywhere to complete a data science project. It's not something like you would always choose the machine learning algorithms to do the data processing. Okay, there's the art, there's a strategy to use what at which levels. Okay, to data processing, to clean the data, to modify the data. We don't need the machine learning. Okay, we need the data analytic tools. We need the data exploration tools. But when it comes to computation, training, we need the classical machine learning or we need a deep learning. Okay. But then what is the use of getting expertise in Python programming or programming language? Because you need to make a pipeline between these different components. How do you make the pipeline? Through your scripting, your algorithm making skills. So if you are so good on writing program quickly, you are quickly able to connect these pipelines and you are able to get the outcome. Therefore, you are quickly able to complete your project and you will get the bonus, right? So this is how everything working together. We should know about the platform. We should know about the end-to-end development, front-end, everything. We should know about how AI ML working out, especially we should know about big data handling. Okay, you may think when I will reach this stage to learn everything. You don't need to do it in a year, okay? You always start with scratch, slowly building yourself. Definitely it will take 1 or 2 years. You need to build it with full heart as a full end development, full end deployment development, okay? Then, after a couple of projects, you will gain the expertise. You will get an opportunity to use that expertise. You will gain confidence more, knowledge more. That is how we are building ourselves in this data science. Okay. This entire data science, whatever we have discussed, is now going to be applied on astronomy. Okay. Whatever we have discussed with the data science, now we are going to apply it on astronomy. Okay. So we know about astronomy, right? I'm not actually talking the astronomy from the fundamental. We know about the astronomy. We know about the modern telescope. We know about, I guess, otherwise, if you don't know, you can easily get it because everything available in quick browsing, right? From the quick browsing, you are able to get it. So about the modern telescope, about the high resolution detectors, about the ground telescope, space telescope, all the informations are available about how to send the spacecraft to the orbit, about which rocket launches, I mean, which launching vehicle you have to use, about the current run, everything is available. But what is not available openly, how to use the data science the technology into the astronomical data that is not openly available, right? It is available in the form of journals, in the form of papers, in the form of courses, in the form of articles. But how do we gain skill on that particular domain? How to blend data science and astronomy just by doing it, just by practicing it. For that, we need to start from scratch, right? Yeah, this is how I started. That is why. Okay, guys. So we are now getting into next chapter, which is data science in astronomy. So let's start with why there is a need of data science in astronomy. Why there is a need of data science in astronomy. Okay, why there is a need. So we are currently having very good telescope. Okay, very fine telescope, Hubble Space Telescope. See the images, right? How beautiful. How beautiful those AI-based images. How beautiful. So previously, like 20 or 30 years before, we were not having this much beautiful images, right? But now this is possible. So technology is there. Then what's the issue? What's the issue? Why there is a need for data science? We applied AI just because of the data science. Okay. So what is the issue actually there? Why there is a need to put data science within the astronomy? Why there's a need? So when you are quite able to collect more data, big data in terabytes, petabytes, about the celestial objects, about the galaxies, about near about the galaxy, about the space. When you are able to collect information about the space, just imagine if you don't know how to handle it. Do you? I mean, are you able to develop the right data platform to handle all those data? If you don't know anything about data handling, just the data keep on coming in. As soon as we set the telescope taking everything and keep on sending it. Okay. So you have to build data centers in the scale of every home on the earth, right? Because data, that much data is there. We know about the space. Okay, we are like a tiny particle. Okay, very far worse than tiny particle. So it's just humongous. The space data is just humongous. So that is the issue. That is the problem. Okay, now to deal with such big data, some technology must be there, some tactic must be there. That is why we need to learn data science if you want to become an astronomer. Okay, as a hobby. If you want to become an astronomer as a hobby, okay, that time also you need to learn data science. Otherwise, you shouldn't interpret everything by yourself. You always go for purchasing some products which is coming with good data analytics tools. Okay. So if you want to build everything by yourself, if you want someone should hire you for your data science and astronomy skills, you should know a lot about data science. Okay. Great. So this is the reason, this is the need for the incorporation of data science into astronomy to handle the data, interpret the data, diffuse the data, clean the data, store the data, use the data, okay, and get the extract the insights out of the data. For all those reasons, we need data science. Okay. Now, in particularly astronomy, how we are exactly collecting the data. We have a ground-based, space-based telescope, which is equipped with increasingly more sensitive cameras and instruments, which is doing surveys, And I am here listing out few surveys: Kepler, Gaia, DES, SDSS, DESI, LSST, Equalate. Okay, these are all survey names. So these are constantly collecting the data. And a decade before, okay, before the revolution of this data science, Python, AI, everything, the wavelength data, which means in a electromagnetic spectrum, we are having different spectrum, optical spectrum, radio spectrum, ultraviolet spectrum, X-ray spectrum, lot of spectrum, right? So for an optical astronomer, I mean, whoever using optical spectrum images to do the exploration are known as optical astronomers, and whoever using radio images to do the investigation known as radio astronomers, who were using ultraviolet band to do the investigation known as ultraviolet astronomers. Okay, so they have used these facilities. Optical astronomers use this facility, image detection and analysis facility. Radio astronomers used this facility, and ultraviolet astronomers also used other facility, especially they have used this language. This language has helped them to handle the big data with respect to the data platform. Okay, this is just a language, something like a Python, something like a Fortran, something like a C++. Okay, but in current trend, this language is forward by so much feasibility, which is now coming with Python or capital R. All programming is also there. Python programming is also there. Okay, and this Python changed everything. Okay, because of its open accessibility, easy usage, and very simple syntax. Okay, everyone started to develop packages. Everyone started to develop packages. If you have your own idea, if you want to give it to society, you can build your own packages, put it into website. Someone will use it, and someone will develop product based on that. You will not get the credit. You are serving the society, right? You won't get the credit, but this is how people are keep on developing Python packages. That is why Python is becoming famous. Community support is there. If any error comes while you are developing code in a Python, it will directly link you to the browser, right? The IDE, and there will be so many thumbnails where you find your relative answer. That way you can sort it out. You don't need the help of your superiors to do the error-free Python coding. Okay, you can sort it out. It's just a matter of the Googling skill. And you should know about programming also. Okay, you should know where to search, how to search. So this is the beautiful thing with Python. Because of this Python, people are developing so much packages, so many packages. Those packages are helping a lot in all the domain, including astronomy also. Including astronomy also. Okay, great. Now coming to big data again, because astronomy is all about big data. We need to give importance to big data a lot. So there are two major characteristics of modern astronomy. One is multi-wavelength studies. Multi-wavelength studies, which includes all the band of, all the spectra of electromagnetic spectrum, as well as multi-messenger studies. Multi-messenger studies. Okay, what is this? There are some other physical phenomena happening in the deep space. Something else is happening. Okay, there are so many core collapsing. There are a gravitational movement here and there for a massive object. A lot of stuff is happening there, right? So those are those physical processes are also releasing the ripples, releasing the ripples. Okay, cosmic rays releasing the ripples, the gravitational waves releasing the ripples, neutrinos releasing the radiation. It is very hard to detect the neutrinos. So we collect all these readings, we collect all these readings. Okay, and these readings are known as multi-messenger studies. So multi-messenger studies are also accumulating the big data. Multi-wavelength studies is also, which includes the different spectra of electromagnetic spectrum also, giving you more data exponentially, exponentially. Okay. So when it comes to big data, we really need to know about how to do the data acquisition, how to store it, how to analyze it. Currently, astronomical database and archive contain billions of objects. Objects are nothing but blob. These objects are stored as blobs. NoSQL database storing its inner element as blobs. Okay, blobs observed in various wavelengths, both galactic and extragalactic. It's just a vast amount of data. Okay, vast amount of data coming from those surveys. How you are going to stretch it into astronomical proportions? Whatever we have learned in the data science, whatever we have discussed in the part of data science, we are putting it here. Okay, how we are going to work on a big data, thereby to stretch it into astronomical proportions. Astronomical proportions. Started with the summarization, classification, regression, clustering. What is this? We are dividing the data into number of components. Then we are doing the filtration on the data. We are grouping the data. Grouping the data coming to this category, clustering and association. And using those data to do some regression analysis that is falling to this time series analysis also. We can do the summarization also, and we use this outlier and anomaly detection approaches to remove the invalid data, okay, from the big data. So in order to achieve these methods, in order to do these methods, we have to do these sub processes. Okay. So we have discussed these processes a lot. It includes mining, visualization, understanding, pre-processing, storage, transformation, collection, lot. So what is the key take from this particular slide, from this slide? Big data could be diffused into number of components according to our requirement. Then we are able to use it for our requirement. We are able to extract the information. That way we are able to use it for our own betterment. Okay. To know more about the astronomy. That is the key take from this particular slide. So I am just listing out few journals. So this link is carrying to this journal page where you will find nice articles about the recent development happened in the big data era of the astronomy. And this link will carry you to another one conference proceeding where you will find great details. Okay, this is released recently, just 2021. And what is actually challenge coming to data science in astronomy, especially handling or dealing with big data? What is the challenge? Challenge is need we knew already, right? When we are doing the data processing and data modeling, what is the biggest challenge we faced? Which is curse of dimensionality. Curse of dimensionality. Okay. Feature extraction, feature importance, diffusing the data into number of components and converting the massive data into structured data is not an easy stuff. Okay, it's not easy stuff. Just imagine all of a sudden you are given with 100 terabytes of images. What do you do? What you can do? All of a sudden, in front of you, 100 terabytes of data given, and they are just telling you, do the data modeling. These are coming from SDSS. That's it. This is related to Milky Way galaxy. Do the data modeling. Get me the insights. Get me the black hole out of it. What you can do? Okay. So it is. I mean, it's art. We need to go step by step. Proper care should be given. At that time, there will be so many errors, which will become headache. Okay, due to the number of subcomponents after you diffuse your brain data into subcomponents. Okay, if you get number of subcomponents, more number of subcomponents, you will be like swinging there to choose to eliminate which feature and to choose which feature. You need to give the feature importance with the right proportion. Of course, there are tools out there, tactics out there, but you should know that, right? If that tactic is not working out, if that tactic is recommended from the Google, okay, if your data coming with 1 lakh features, use PCA, principal compound analysis, and do the data modeling, you will have the better outcomes. But I tried it multiple times. There were no outcomes. PCA is there. Even with hyperparameter tuning, I tried it, but no outcomes. What we can do that? We can't just ignore, right? We have to find a way. So it will literally become a curse, headache. That is why this term is becoming a challenge, particularly when you are dealing with astronomical image, because there is no end. It is completely infinity. Okay, there is no end. You will be getting data again and again. There is no stopping. But you need to bring out the features somehow. So ultimately, it will become headache. Okay, that is why this is the challenge when you are dealing with the big data in astronomy. Okay, yeah. And finally, ML in astronomy. So there's a, I mean, we use ML for predictive modeling. After we got the structured data, we use the ML to do some predictions. Okay, we discussed about it a lot. Okay, so this slide is just here to address the importance of ML, machine learning in astronomy. And what about astronomy data particularly? What do you mean by astronomical data particularly? Just astronomical data. See these divisions. Okay, we collect astronomical data from different survey and different divisions, and this is how we are, I mean, able to classify it from the first hand. spacecraft imaging data from solar system missions, spacecraft survey data from exoplanets, sky surveys at radio, infrared, and optical wavelength, data sets from gravitational wave detectors, cosmological simulations of large-scale structures in the universe. Okay. So these are all different mode of the data we can have from different missions. Okay. So if you check carefully, everything is relating to image and the data related to that image. Okay. Everything relating to the image and the metadata relating to that image. Okay. So we obviously need a better, very good data structure. Even though it is coming under the category of big data, doesn't matter. We need a best data structure, okay, to handle these variations in the data. Because it's not just a data, it's a data coming with some information. There must be identity, right? If you are photographing me and if you want to know me, you should know about me. Definitely, you will gain interest. You will gain information about me by looking at the photo. He is black. He wears specs. Okay, he's okay. But when you are getting the data, when you are getting the photo of me, if you know about me at that instance, that would be pretty much helping to know better, right? That is the objective. So we really need a data structure, a data type, which should be helping here in this task, image and the data. So we have numerous file formats, GIF, PNG, JPEG, TIFF, PGM. So we know about GIF, some animation stuff in Google, right? And PNG, JPEG, TIFF, PGM. These are all not helping. These are all not helping. These are all only storing the image. Of course, you can able to extract the information, but we need to store the image with with metadata, with the informations about the image, the fundamental informations about the image. So we need something else which is FITS, FITS, which is FITS. Okay, FITS stands for Flexible Image Transport System. Flexible Image Transport System. Coming to FITS. So this is the inner component of the FITS. This is nothing but a single file of fits, only one fits. If you take out only one fits, that only one fit will be having four block. Okay, we'll be having four block. The very first block is known as header block. The upcoming blocks are known as extension 1, extension 2, extension 3, till extension n. So each block is now coming with a data and a header. Each block is coming with a data and header. So data is where we keep the data of an image. Header is where we keep the informations about the image. What is the mechanism used to do the survey? Who originated the survey? Which industry originated the survey? What was the reason for the survey? What was the calibration of the instrument they have used? What was the year? What was the duration of the experiment? What was the data pre-processing has been made on that image? Okay, and whoever accessed already this image, okay, and is this image related to any ground-based survey? Everything about the particular image can be put up into metadata. That metadata always coming along with that image in blocks. Like that, we have n number of blocks, and this is known as fits. This is known as fits. Okay, FITS. This is known as fits. Fits are pretty much helping. Fits are pretty much helping to understand more about astronomical data science. Okay. If we know about fits, how to create the fits, how to add more block to the fits, okay, how to extract the fits, how to brought the data out, how to do the inner engineering on that data. If you know about that, it means you know something, you know everything in the better scale. Okay, you can be proud by yourself. So this is where we have to start. We need to understand about astronomical data structures. People are keep on using it widely. Then we need to learn it, how to use it. Based on that, we need to build our data science skills. Okay. So this is where fits are pretty much helping. And coming to Python packages, helping the astronomers. This one comes every time at first. AstroPy. This AstroPy includes all the tools, visualization tools, convolution tools, feature extraction tools, filter tools. Okay, you are eligible to do all image processing relevant functionalities on the image you are extracting from the FITS data using the AstroPy. Okay, this is pretty much helping. And what about Scikit image and OpenCV? These are all also helping, but these packages are made not only for the astronomers. Okay, these packages are made to handle to deal with any images on every domain. Okay, but AstroPy is made only to handle with astronomy data. Okay, now coming to stellar population synthesis. So this is the leading research domain, okay, because here we are blending the physics-based modeling to the machine learning and data science. Okay, this is quite interesting. People are doing a lot of research. So what is this actually? So there is a galaxy, actual galaxy. So telescope will take readings from that galaxy, and those readings will become data, will become big data. So there will be data reduction, data processing, data cleaning, everything. And finally, you got the right insight, and that is known as observed data. You keep it aside. In this end, you have some simulation ideas. I mean, you have some fundamental ground level ideas from the data which is available in past. From the data which is already available with you, you are just simulating something in your mind, and you are just producing it as a physics model. You are just producing it as a physics model using some mathematics, using numerical algorithms. Then you are putting it into computer simulation. That is going to give you some insights about the data you had about the same galaxy in past days. That is now compared with the observed data. So the old data and the insights compared with the new data for the same galaxy and the insights. So there will be a continuous monitoring made possible, right? People are doing continuous monitoring based on like this, based on this. No one is able to sit and take a photo shot of the image and manually checking it and get the insights nowadays. Maybe they have done it some decades before, not nowadays. They have the algorithm, they have the everything. So continuous training every day when the data coming from galaxy, it is given to an automatic model, which is learning automatically. Okay, that is compared with the real-time data and the readings and the insights comes out given to the observer for taking decisions. Okay, so if being a data scientist, if you reach this level in your life, okay, after 4 or 5 years of experience, if you build the application by yourself, which do this, okay, you will be, I mean, you are a gifted person. It is very hard, very tough. Computer science side, we need a good knowledge. Astronomy side, we need a good knowledge. Programmatic side, we need a good knowledge. Okay. Yeah. So a single individual, I mean, individual personalities can't do this, but people are trying and publishing their post and making it real, making it happening. Okay. How exactly we are using AI there? How exactly we have used AI there? The data we receive is split into, I'm just talking about the past data. We received is split into two part, training part and test part. So we used the training part to train the machine learning model, and we used the test part to validate the machine learning model. Okay, that is how we are using the AI ML in data modeling. So here we are actually using the AI everywhere. Okay, in the left side portion as well as right side portion. When it coming to the stage before the final inference, we are using the AI. Okay. Without AI, this is not possible. But data science is also coming here. In the right hand side, the first two blocks is completely data science, and the third block is a data analytic. Okay. And in the left hand side, the first three blocks are nothing but the second two blocks are nothing but complete data science. Okay. The area where we are extracting the information is where using the ML. So data science, ML working together, creating beautiful architectures. Thereby we are creating interesting models, beautiful models, high complexity models. Okay. So this is a leading research going on with data science in star formation evaluation. Okay, great. And this is the link. This is the link. Okay, you need to use this link to know more about how use machine learning on star formation rates and stellar masses. And coming to data science in cosmology. So cosmology is everything, right? Cosmology is nothing but all the element of the universe, including dark matter, including neutrinos, including all celestial objects, everything. Cosmology. It's not just talking about the stars and galaxies. It talks about the ghost elements, ghost mediums, everything. How to know more about the cosmology using the data science? Okay. It is pretty much similar to the previous one. So we have a theoretical idea. Okay. We have a theoretical idea. These theoretical ideas are in the form of numerical methods. Numerical methods, okay. Or the one-dimensional equation, two-dimensional equation. So we have a theoretical idea. We are using these theoretical ideas over the existing data. Whatever data we have related to this over the existing data. Okay. Thereby we are creating a new data only meaningful for dark matter power spectrum. This is again a new data. This data is now getting used. Okay. So till here we use data science a lot, not a machine learning. This data is now given to a neural network. Neural network. Okay, we have a neural network. This neural network configuration is known as Bayesian neural network, completely different than CNN and RNN. Okay, more of like RNN, more of like RNN. Okay? Pretty much helping for time series forecasting. So this neural network is trained with this data and optimized with this data. Now it is going to take all the readings, the new readings, the real readings, real-time readings coming from the cosmology. It will classify, it will do the prediction about the dark matter power spectra. Okay. This is how we apply data science on cosmology nowadays. Great. In astrophysics and particle physics, how we are using the data science? Astrophysics and particle physics. Okay. So in our world, okay, not in our world, in our Earth, in Switzerland. Okay, so in Switzerland we have an accelerator facility which is known as Atlas and CMS detector. Okay, so here they are conducting experiments to know more about God's particle, to know more about the dark matter, dark energy, thereby complete evolution of black holes. Everything is connected. So they are doing the experiment and they are creating a data set in the rate of beta scale. Beta scale is nothing but 10 power 15. 10 power 15. Okay. So this data set is only meant for either classification or prediction. It doesn't have any images. Okay. Of course, if we want images also there, but most of the time this data coming with classification based and regression based. So no images, but more instances, more records. So the size around 10 power 15. So we use this data to know more about the signal event and background event. Signal event and background event, which are helping to understand more about dark matter, Higgs boson, dark energy, everything. So if you want to gain your data science skills on astrophysics and particle physics, you know a lot about physics. But again, you need to know a lot about data science, and you need to blend it. You need to know how to handle the big data, because it is keep on releasing data. Okay, so we need to know how to handle this. Then coming to data intensive astronomy. So data intensive astronomy is the part where we use a less data science tools, but a more predictive tools. Okay, more predictive tools. Here we are straight away focusing on the sun. We don't mind. We don't mind about the data clarity, data cleaning. Obviously, we need to mind, but less importance we are giving there. We need the intensive care on extracting the information. We are so intensive. Okay, we are so intensive. So machine learning, high complexity architectures are used here a lot. High complex architecture, which defines the complexity of the architecture of a machine learning. The statistical strategy defines the complexity of the architecture. What's the difference between machine learning architectures and, sorry, classical machine learning architectures and deep learning architectures? Classical machine learning architectures not behaving with that much complex statistics. Okay, very less statistics. Coming to deep learning, more statistics used there. Okay, more strategies used there. Then the architecture is just extending itself. Okay, we are able to add more part of the architecture. We are able to increase the complexity. So we need such super high complexity architectures for the sake of extracting the information with high perfection. Okay, this is a big data. This information, this is the extract information coming from a big data. Okay, so here this is actually a cluster. Okay, so each group is given with a different color. So blue is there, green is there, dark blue, light blue, green, orange, brown, black. Okay, all these colors are here, right? So each colors are representing each galaxy group. Each galaxy group. Okay, so this is the observation we want at the end. We just need to send the data there. That's it. The algorithm you are going to develop, the architecture you are going to make should have the ability to check the data frame by frame and permit the data into data modeling. There we get the insights out. Finally, get all our analytics out. Okay, for a good data visualization. This is what exactly we want when we are dealing with astronomical data. Because we shouldn't be worrying about how much memory the data goes in. Okay, it could be a big data, a light data, doesn't matter. But at the end, we need visualization like this. We should talk about the data with more perfection, more clarity. Okay, yeah. And if you check out this link here, almost everything. Okay, this PDF, I shared the link. Almost everything how in recent days AI is used in astronomy. Okay, they have listed it very well, and it released in Singapore recently in a summit where in the year 2023. Okay, this is a very new paper. Okay, open source paper. Okay, please take a look at this, and you will have better ideas. And coming to career opportunities, so yeah. Okay, guys. So yeah, I'm continuing because we are almost there to. I mean, I'm almost there to complete my part. So career opportunities. So far, what we have done. So we have checked about data science. We checked about various part of the data science. We checked about how data science. We checked about database management system, and we have checked about astronomy, big data, everything, and how we are using the data science into astronomy. We checked that part also. Okay, and I have given you some examples of articles also. Now coming to career opportunities. Okay, I guess most of you are doing your academics, and in the beginning we got to know each other. So I got the idea about yourself. You are actually seeking some career, right? So that is what I'm going to do. So this particular slide is giving you a much elaborative information about what are the different sectors. Okay, available all over the globe, which is dealing operations with space. So this particular slide giving us some interesting idea about what are the different agencies, how space explorations carried all over the globe. Totally more than 130 government organizations are there, more than 150 research hub organizations are there, more than 10,000 companies, more than 5,000 investors. So it is already everywhere. The thirst to do space exploration, thereby to create investors, thereby to create a company, is now like everywhere we can find in the globe. Okay, it's not only happening in India, everywhere in the globe. It's not only happening in United States, also everywhere in the globe it's happening. And here we find some ratios, the company regional distributions in 2021. So United States covers most of the companies, and India is also in the race. Chinese, Germans, United Kingdom, Canada, everybody is contributing their space exploration. And coming to budget in millions, again, United States is a big sector. China comes next, Japan is there, India is also there, Germany is there, France is there, and almost all the nations are doing it. Okay, all the nations are spending some money to do it. And here I listed some titles. Okay, so based on our discussions, I guess now you are pretty much sure and confident about the various roles, right? So here I listed the various roles. If you choose to become astronomer with data science, if you choose to become astronomer with data science, these are the different roles you can find in different industries, institutions. Okay, data analyst, data engineer, data scientist, data visualization expert. So all these people need a programming language, a knowledge over database, data visualization tools, knowledge on statistics, knowledge on mathematics. Okay, they really need to know that, right? And coming to here, astrophysicist, astronomer, data management, research engineer. Okay, these people are also falling to the same category on the skill. They need Python. They need to know the programming language. They need to know how to, I mean, these titles are only meant for how to study yourself, how to have a good career in data science. Okay, this is not actually combined with astronomy. If you learn data science without astronomy, you are quite eligible to have these careers. Data analyst, data engineer, data scientist, data visualization expert. If you know only about database management system, Python programming, data visualization tools, data analytics tools, and a couple of projects, okay, you are quite good. You are quite eligible to start your career as a data scientist. Maybe a graduate data scientist or junior data scientist. Okay. But if you want a career with astronomy, you need to know about how data science is collaborating with astronomy. Okay, you need to explain. You need to know the fundamental thing, at least fundamental stuff, at least about how to incorporate both astronomy and data analysis. I mean data science. That is really important. Then only you can able to do the PhD. So if you want to become astrophysicist, you need a PhD. You need different programming languages, and you need to know how to do the astronomical data analysis, which is nothing but usage of data science and whatever we have discussed with the astronomical data, how to use it. Okay, you should know that too. And to become an astronomer, observatory astronomer, or we have checked different regions, I mean different astronomers, right? Optical, radio, whatever be it, you need to know how to handle your data with data science. Okay, how to extract the data through data science. Okay, and if you possess PhD in astronomy, that would be great. And coming to data management again, yeah, these are relating to data platform management systems. So you need to know about database, you need to know about cloud computing, you need to know about big data, okay, and all the programming languages. And at the end, the research engineer, okay, this is something interesting, right? So dignity, I mean high profile industries, high profile institutions usually usually need a people who are doing a lot of research over astronomy, real time research. So it requires computer science, because without computer science you can't do the astronomical data analysis, or a thorough knowledge about various data platforms, various data analytic tools is also good enough. Okay, you don't need to all the time a computer science guy to start your career in astronomy data science. Okay, you can easily learn if you get yourself in the right institution, in the right course. You can really easily learn about everything, about all the elements of data science. Okay, it's in your hand, because I am completely belong to aerospace. I knew only the machines, mechanical machines. Okay, aerospace engines, jet propulsion, rocket dynamics, kinematics. But see, now I am taking a webinar on ADS, astronomical data science. How? I learned everything by myself. Okay, I got myself into self-learning. I'm learning. So this is possible for me. So for you also, this is possible. You don't have to belong to computer science all the time. Okay, you could be anyone. You can able to learn everything by yourself to shape a career. Okay, so please keep that in your mind. So there are nice careers you can have if you choose to do some collaboration between the data collaboration with the data science and astronomy. Okay, that will be nice career. Please have that hope. And I just give you some link to know more about these opportunities. Okay, so here are some statistics also given. So please check these links. And coming to ourselves, so we are Spartificial, and we are a tech company. We are building tech stuff with AI, okay, to assist space exploration for a different client. But along with that, we are providing, this is our another part of the service, another part of the work. We are just giving our learning, our experience as a program, okay, as a program. So I am the one handling everything in the academic part. There are people out there to handle in the industry part, okay. So I am gaining knowledge from them, okay, and everyone is sharing our knowledge. And I mean, we are actually very good at that. So we have quite programs. So this program is all about astronomical data science with Python. This is the complete information about the program is already there in the website. And the instructors are coming from Aryabhatta Institute and ISRO, and I'm also one of the instructor. So the curriculum, this is the curriculum. So there will be like 10 weeks, okay? And I listed everything. It started with the basic introduction of Python programming, and it started with understanding about the computer vision, AI, everything, and data analysis technique, data visualization, and how to do the image processing. Finally, we use some machine learning, computer vision techniques to build an amazing project. Okay. This course is there in the website. You need to check. And this is a nano degree program we are introducing. Okay, so it will be commenced on April, I think, and the advertisement is there in the website. So this course is actually a 16-week course. 16-week course. Okay, and a lot of stuff we are discussing here more intuitively. Okay, and this nano degree program is pretty much equal to a diploma, more than a diploma. Okay, so week one, we started with the basic astronomy. Week two and three, we started with Python programming, and week four, five is again we are going depth there in machine learning and astronomy to know more about data analysis, the image processing. We are just digging deeper and deeper. And week 10, we are going to concentrate only on. We'll be concentrating a lot, but our main aim towards the radio astronomy. Okay, in week 12 and 13, we will get into advanced topics. Okay, what we discuss, stellar stuff, right? Stellar synthesis. We will get there. And week 14 and week 15 is like astronomical some career guidance will be given. Okay, and the conclusions, and it is followed by internship also. So this is a complete idea about the nano degree program. Okay, if you're not getting enough idea right now at this moment, don't worry. Just check with my team. They will have I will they will always there to help you. And this is another one course, fundamentals of astrodynamics in Python. Okay. Astrodynamics and Python. I'll be handling it. I'm a aerospace engineer. I find no trouble there. I'll be handling it. And some other faculty member is also coming from IIT based stream. Okay. So this is started from week one as an introduction to astrodynamics, then two-body problem, then orbital elements, orbital determination, everything about orbital mechanics will be taught. Okay, with Python. Okay, you need to realize the value of the course we are just giving out. Okay, that is the biggest worry for of us. The people need to realize that the cost is not something big. Okay, it could be like bearable, but you need to use it. So orbital mechanics with Python, if you learn it, maybe this could be your head start. Maybe this could be your scratch course. But if you extend your journey on these foundations, one day you will find yourself in nice space agencies. Okay. That is the dream. That's how we have to dream, right? So if you want to pursue a career, initially everything looks so basic, so scratchy, so boring sometimes. Okay, because you are learning a technology, you need to pay attention towards this. You shouldn't give up. Okay, you shouldn't give up. You keep on learning. Even after the course, also you shouldn't give up. Okay, that's what I am telling you. I wasn't giving up. Okay, when I was doing my transition from aerospace, ordinary aerospace into AI-based aerospace faculty here, I wasn't giving up. Yeah, I have been working till to learn more. I have been working to learn more. There is no end. So you need to have that spirit. You need to keep on learning. Okay. So these courses are going to help you. These courses are going to help you. If you don't know anything about it at all, don't worry. These courses definitely will help you to start everything from scratch. Okay, at the end of the course, you will have a good idea, and if you will be particular even after the course, you are able to extend your search there, and you will able to learn everything. Okay, yeah. So, and we are also offering guided projects. Okay, this is this is recently initialized by us. We are helping the academicians to efficiently do their academic projects. Okay, the instructions are mentioned in the website. Please check. And we are doing a workshop also. There's the information available in the website. So it will be commenced on March, 14 days workshop of totally 7 sessions. So the title of the workshop is Problem Solving for Space Science with Python. Okay. So there will be a 7 day session, and what we'll be covering in that workshop, everything is mentioned here. Okay, great. And obviously, to know more about us, you can use this number and you can mail, you can use the Instagram. Okay, always please keep in touch. And you can use this barcode as well. And yeah, this is it about about this webinar. So as a conclusion remark, we have discussed about almost everything. Okay, we have started with data science basics. We learned about data science tools, data analytic tools, database configurations, and we have discussed about the machine learning. And we discussed about how to incorporate data science into astronomy a lot. We have checked some application. We got to know the importance of neural networks as well. And we have discussed about the career opportunities wherever you can find nice careers. Okay, and how exactly, if you are a fresher, how exactly you can build your career. We are there to help you. So please keep these informations always with you. And yeah, if you are interested, please register our courses, and we'll be helping you to teach. Okay. So that's all about from my end.